The next problem statement is binary search. To search an element, to search an key element from the given list of elements using binary search. So one thing we need to remember over here, whenever we are going to use this binary search, so the elements need to be in sorted order. The elements need to be in sorted order. Hash include stdio.h, int main. Now let me take some identifiers which are related to this program. So the identifiers which I require are int I for iterations. Let me take first, last and the mid position. Next, number of elements n. The element which I want to trace from the given list of elements, or the search element, I call it as key, and I have initialized an array with some size. So these are the different identifiers which I require as part of the code. Now first let me request the user to enter the number of elements in the array. Scanf %d address of n. N is for number of elements. Next, this is how we are going to request the user to enter the number of elements. The next one is printf enter the elements. So let me enter the elements now. So in order to enter the elements, we require one for loop because we are using one dimensional array. For I equal to 0, I less than n, I plus plus. So this is how we are using to read an element in an one dimensional array. This is array of I. So this is to read the elements in the array. Now the next one is we need to request the user to enter the search element or enter the key element to be searched in the given list of elements. Enter the key element to search from the given list of elements. Scanf. Now I am storing that key element in identifier called key. Now I have stored this key element. So the logic behind binary search is, whenever we are going to search any element, the first thing is try to input the elements in the sorted order. If you are not inputting the elements in the sorted order, then again we need to sort the elements first, then we need to apply the binary search technique. So the binary search logic is, first we are going to allocate the value of first as 0, and the value of last equal to n minus 1, whatever the number of elements are there. So number of elements minus 1, and here we need to find the mid element, mid equal to first plus last divided by 2. So from the mid element, if the element, the key element, whatever we are going to search, if it is greater than mid, we are going to trace on the right hand side. If the key element is less than mid, we are going to trace the left hand side element. So as we know the logic of the binary search, now let us try to implement it as part of this binary search. So I am going to use a while loop. While first is less than or equal to last. If this condition is true, now I am entering into the loop. Here I want to check if the given array element in mid position, I am going to trace with a mid position, right? So array of mid. So randomly, depending upon the number of elements, whatever we are going to give it, so we are going to get this value at runtime. That runtime value we are going to refer for the mid position element. Array of mid is double equal to, or let me just first check for the condition of, if array of mid is less than the key element. If the array of mid is less than the key element, then I am updating the value of first. To first equal to mid plus 1. So I am updating the first value as first equal to mid plus 1. Next, else if array of mid is double equal to the key element, now I am going to give the value of the search position, that is printf, the given element percentile D is present at location percentile D, comma, here the first one is key and the next one is given mid value plus 1, because to give the accurate value I am using this mid value plus 1. And immediately if we encounter the element, now we want to come out of this particular search process. We want to immediately come out of the search process. Next, if these two cases are not satisfied, then just I am updating the last value equal to mid, whatever the mid value minus 1. So if it is mid is less than key, I am updating the first value. If the array of mid is double equal to key, then I am displaying the value and I am coming out of the loop. And if this case is not satisfied, then I am going to the last case, that is else last equal to mid minus 1. So we are reducing the mid value to minus 1. Now after this step, the next step we need to use as part of this particular while loop is we want to update the value of middle as well. Now I am going to change the middle value for every iteration, that is mid equal to first plus last by 2. Then I am updating the mid position. Again I am going to check from the beginning. As the first and last values are updating, so every time this part and the else part is getting updated if your element is not found, and every time you are updating the mid position value. So here my key element is traced depending upon my mid value. So the mid value whenever we get accurately as part of your key search element, that is array of mid position equal to key is double equal to key, then we are coming out of this. So this is your actual logic what we write for the checking of the, or this is what the actual logic what we write for searching an key element from the given list of elements. Next, so after this while loop, just I am going to check with this condition. If whatever the first is greater than last, if first is greater than last, then I am displaying a message to the user stating that the search element is not found. The given element percentile D, or I will be changing this message, the given key element percentile D is not present in the given list. The key element percentile D is not present in the given list. So this is what the message which I am going to give to the user if the search element is not found in the list. Now here the percentile D is key, the key element, right? So this is how we are going to trace or search for a element using binary search. So this is your logic. Please do concentrate on this logic part. Now let me execute this code and check whether the given element is found or not. There is some error. I missed somewhere a semicolon. So here I have missed the semicolon. That is what the error message which I got. So once again I am executing the code. So here enter the number of elements in the array. So I am giving the number of elements as 5. The number of elements is 5, which means now I am entering the elements. These elements need to be in the sorted order. Totally there are 5 elements. Now if there are 5 elements in this, the mid element will be 3. The mid position will be 3. Now enter the key element to be searched in the given list of elements. Now let me give the search element as 4. The given element 4 is present at location 4. So we got it. Now let us trace this code and understand how our logic is functioning. So the first one is we are going to read the n value. N value is 5, and I have read 5 elements in the array in the sorted order. If the elements we are reading are not in the sorted order, then we need to write one logic to sort the elements first and then apply the binary search technique. Now As of this particular code, let me give the elements in the sorted order. So the elements after entering into the sorted order, I am going to give the search element. That is the key element what I want to search from the given list of elements. Now here first equal to 0 and last equal to n minus 1. The first index I am storing it as 0 and the last index I am storing it as n minus 1. Now in last, what is the value we have? In the last we have n minus 1. Last equal to n minus 1. N value is 5. What is 5 minus 1? 5 minus 1 is 4. So 0 plus 4 by 2. 0 plus 4 by 2 is 2. Now in the second index, that is mid. Now mid is pointing to 2. So 2 is nothing but here the value is 3. Now check the condition with the logic. If, so coming into the while loop, first less than or equal to last. If array of mid. Now what is our mid value? Mid value is 2. Okay, according to this we got the mid value, that is 0 plus 4 by 2. 0 plus 4 by 2, that is 4 by 2. We get the value as 2. Now the mid value is 2. In ARR of 2, what is the value we have in ARR of 2? 3. Is 3 less than key element? What is the key element we are searching for? Is 3 less than key? The key element we are searching is 4. 3 is less than 4. This condition is satisfied, which means now we are updating the first value equal to mid plus 1. Now we are updating the value of first equal to mid plus 1. Mid value is 2. What is 2 plus 1? 3. Now immediately after this, if part is executed, then go directly to this mid. Mid is equal to first plus last by 2. Now what is the first value? The first value is mid. Mid plus 1. Mid plus 1 is 2 plus 1 is 3. First value is 3. 3. What is the last value? Last value is, earlier we got n minus 1, right? N minus 1 is 4. Now what is 3 plus 4? 3 plus 4, that is 7 by 2. 7 by 2. So 7 by 2 here we are going to get as the integer value only. Because we have used integer, we are not going to get any float value. 7 by 2 we get 3. Okay. 7 by 2 we get 3. Now here again we need to go back here. What is the first value? First value is the updated first value. 3 is less than or equal to, what is the last value? Last value is n minus 1, that is 4. Okay. 3 is less than or equal to 4. The condition is satisfied. Now let us check array of mid. So what is the mid value now? Mid value is 3. Array of 3. In array of 3, what is the value we have? 0, 1, 2, 3. In array of 3, we have the value as 4. Is 4 less than 4? Is 4 less than 4? The condition is false. So if part is not executed. Next, else if, let us go into this part. Array of mid. That is, what is the value in array of mid? We have 4. Is 4 double equal to 4? 4 double equal to 4? Condition is true. If condition is true, the given element 4 is present at location mid plus 1. The mid value is 3. 3 plus 1 is 4. So we get the message like this. The given element, the given key element 4 is present at location 4. That is what the message we got it. So as soon as the message we got it, we have used a break statement. So what is the use of this break statement is, it will make the control to come out of the while loop. Now your control is coming out of the while loop from here and it goes to the if part. If first is greater than last, what is the first value we got? The first value, whatever the updated first value is 3. Is 3 is greater than 4? Last is 4, right? Is 3 is greater than 4? No. So definitely we will not get this printf message. That is the reason we got this. The given element 4 is present at the location. So let me execute this code with one more test case, and you can understand how to process the internal steps for this, and you can trace out the program. So let me give with the another test case. Let me give the number of elements as 8. The number of elements as 8. So I'll be giving the elements in the sorted order: 11, 12, 13, 14, 15, 16, 17 and 18. So totally I have given 8 elements. Enter the key element to be searched in the given list of elements. So I want to give an element which is not there in the list. So let me give the element as 20. Now you are going to get this error message. That is, the key element 20 is not present in the given list. The last message. So you are going to get this message. The key element 20 is not present in the given list. So if you can see this list, there is no key element which we are searching for, right? So let me run one more test case, the last test case. The number of elements are 6. The number of elements are 6, and I am going to give the numbers as 51, 52, 53, 54, 55. So these are the elements which I am going to give as part of 55, 56. So these are the elements which I am going to give as part of the array. And now let me enter the search element. So the search element which I am giving is, let it be the search element as 53. The search element as 53. The given key element 53 is present at location 3. So you can see this is the first location, second location, third location. The given element 53 is present at third location. So this is how we can execute the code for searching an element using the binary search technique when the elements are in the sorted order.